Hello, everyone. Welcome. I'm happy to be here with you today on this Friday afternoon. The question that we want to address, or the dilemma we want to address, is around the software supply chain. When we build software, we have a dilemma of choosing the open source projects and maintaining them. And we know that with more than 7 million open source components published in the last 12 months, and only about 10% of those being actively used, there is this vast noise of unused open source components. And we also know only a fraction of those are being maintained and actively developed. So this creates an opportunity for malicious actors. And we know this is actively happening. Over the last years, there has been an increase in malicious packages being discovered. And we also know businesses that have been affected by software supply chain attacks today spent $50 billion. In 2023, that is expected to increase to $138 billion. And if you think this is only affecting some companies, think again. Gartner is expecting by next year that 45% of businesses will have been affected by an attack. So now that we know the chance of being attacked, what is the impact? When it comes down to money, what are we talking about? From the SolarWinds example, we know that businesses affected by this spend on average 11% of their annual revenue. So if we take 45%, flip of a coin being affected, 11% attack impact, we're landing at about 5% of annual revenue that we are losing to software supply chain attacks. So this is a big problem that we need to address, and that is what we want to talk about. Luis?
Hello, thank you. My name is Luis. I'm passionate about open source and also about data. I've been working with open source for the last 22 years, and I've been providing insights based on data, based on open source projects and communities for the last 12 years. I'm also a Chaos contributor. Chaos is a project by the Linux Foundation. It means it stands for Community Health Analytics and for the open source ecosystem for open source software.
Thank you, Luis. Luis is on a mission to help open source projects make a big impact and create a better world. I am Georg Link. I'm an open source strategist. I have more of a business focus. My mission is to improve the health and sustainability of open source projects. I've been in open source for more than 20 years, both on code contributions and non-code contributions. I co-founded the Chaos project, which looks at community health analytics, and built that community. So that's who we are and why we are here today. So let's take a step back and identify where does the problem lie. And I want to start out by this metaphor that software ages like milk, not wine. Wine gets better the older it gets. Milk is best served fresh and then becomes spoiled pretty fast. And in software, similarly, it becomes outdated. We discover vulnerabilities, and it generally ages pretty quickly. Now, if you have milk in many dairy products, we have labels that say use by, and we know that if the supplier, a farm, had spoiled milk, we can trace back into what products it was used in. And we have that same thing in software where we maybe not have an expiration label yet, but we have the software supply chain concept. And I'm going to ask Luis to share a little bit what the context is.
I love talking about wine, but let's use this example to see what is happening in the industry. Depending on the reports you see, there are very well-known reports lately. from 87 to 90 something percentage of the current produced components in the industry contain open source software. So everyone is using it. The big success of open source is that everyone needs and uses open source. So what is the risk here? Big corporations, they tend to grow very quickly components because they use open source. And for small teams, they can think that they know the dependencies they have. But if we think about the dependencies, not only the first level dependencies, but the dependencies of the dependencies, then things start getting more and more complex. So this is what we call the unknown risk. Big teams, small teams also, but big teams, they basically don't know about the software they are using. So they have no idea. They may know the license, but there are many, many different topics and points of view that are totally out of the scope. If we focus on some example components, most of the components today, and this is again from another report, they have like 200 dependencies if we think about the whole tree. Not only the first level dependencies that are declared in the code, but the dependencies of those dependencies. This is called the dependency tree. If we think about the dependency tree, there are three ways. There are three approaches that you can use to trust these open source libraries your component is using. The first one is to study license. The second one is to study the vulnerabilities. This means the security errors reported. And the third one is to support the projects or dependencies that are not well maintained. But this is not easy. So for licenses, there are many well-known tools that provide you a list of the licenses for each of the components. So in your company, I guess that you have a list of licenses that you want to avoid. For instance, some companies, they don't like the GPL, so they want to avoid at any cost using GPL. Of course, you will have to avoid the incompatible licenses. This is already solved by many different tools outside. The second set of tools, they give you a list of all the vulnerabilities that your components have. For each version, they tell you the number of open vulnerabilities, so you are aware of the issues of the current code you are using. This is already solved. For the third one, we start entering the gray zone. There are some companies, that are supporting projects that are not well maintained, so they provide you a package with a component and the subcomponents, and they take care of everything to make sure that they are maintained. What we miss here is that in the 21st century, modern software components should make informed, data-driven decisions about the software they are using, and they are not doing it. We think that they should be able to make informed decisions to choose the well-maintained software, and this is not happening. This is happening with licenses, this is happening with vulnerabilities, this is not happening with well-maintained projects.
So we have some maturity here that we need to climb the ladder. And for this, we were conceptualizing a risk assessment model, focusing really on that community risk. And I'll drive home the point again that what we're talking about. So if you imagine a car, you're driving your car, low fuel comes on. What do? You go to the gas station, fuel up, you continue. The engine warning lighting comes on. You go to the shop, get it repaired. That works as long as your car is being maintained. And this is what we have with licenses and vulnerabilities. We know what is the state today. We know how to fix that. When we look at a car that is an old-timer, then you end up in a situation where you cannot get parts anymore. You go to the junkyard, and you have to find a mechanic that is still dealing with old cars. In software, that is where we have under-maintained projects. So that is the problem space we're in. And looking at under-maintained projects, we were considering three factors for what that could mean. One is, can the community handle the workload? And we used the metrics Backlog Management Index and Review Efficiency Index. Second, Can the community address the workload quickly? We were looking at lead time for issues and pull requests. And third, does the community have the right talent or inflow of talent? So how long are contributors staying in the project? Is the community of active contributors growing? And what is the contributor absence factor, also bus factor, or we called it pony factor? We took these metrics and normalized them, aggregated them into one score for each component, for each library that we had, and then combined those. So if we have 180 different packages in our component, then we aggregated those scores together. I want to show you what that can look like. And this is a prototype. So this is something we're actively thinking about how to improve. This is the dashboard, and we'll walk through different components. One, we can filter into specific software components that we're interested in. Here we looked at Kubernetes Golang dependencies. We have on the right a set of indicators like traffic light, green, yellow, red, low, medium, high risk. And we can see how many of our dependencies land in each category. We also had very high risk. Those were the projects that did not have enough activity for us to calculate some of the metrics. And then we can map this in a heat map where we can start to see where the different dependencies land. On one thing here that stands out, the pony factor, the third row from the bottom, there's a lot of high risk. Lots of the dependencies here only have one main core developer. And then we can drill down into the components themselves to see, okay, this one, I just picked a random one, it has a medium risk. Why is that? How does that come to be? So we can look at the individual metrics, and you see the numbers on the right side, and we have thresholds to say this is low, medium, high. And in our experience, everyone has their own thresholds. So this is something that can be configured. And in this case, the high risk comes from the lead time. So now that we know this, we can decide what do we do with this dependency. If we want to continue using it, maybe we can go help the project address the issues and pull requests faster. Or we sponsor a maintainer to do that. Or whatever solution we want to drive forward, knowing where the problem is helps us get there. So that is the risk mindset and how we can get there. And we used an open source tool to get the data, and I'll let Louis introduce that.
All the data you saw in that prototype is collected, enriched, and produced by GrimoireLab. GrimoireLab is a project we collaborate with. It is part of the Chaos project, which is part of the Chaos Foundation. A little bit about the history. When I started working for a research group in Madrid, the former and current colleagues there were working on research reports, on research analysis. And many of them were created their own ad hoc scripts to get data, to publish, to make publications, basically. So the idea was to create a set of tools that was used by the scientific community to create a big data set that could be used and validated by the different projects. So with that idea, we created several scientific publications, and in 2012, some of us created the company, Bitergia, and in 2016, we moved from the old tools to GrimoireLab, which is the revamped version of the old one, which was named Metrics Grimoire. We switched from Metrics Grimoire to GrimoireLab. We started using the Elasticsearch stack. Some years ago, we moved to OpenSearch because we want to stay open source. And in 2017, we joined Chaos. We contributed the code to Chaos. And this year, we released the version 1.0. We are very happy about that. And currently, we are working on the version 2.x with the main goal to scale up, to analyze a really big amount of projects. This is an example of the reports we created lately. This is a bit old, from 2020. It is called, I love the name, it is called Mozilla and the Rebel Alliance. We created this report with Mozillians and with another company. We obtained all the data with GrimoireLab, and we also got the insights that are included in this report. So I recommend you that you have a visit, that you have a look. The main goal of the report was to show the activity of the status of the community, but also the impact of the Mozillians in the open source ecosystem. And those are other examples of different places using GrimoireLab. For instance, OSS Compass, it's supported by several Chinese companies. They provide metrics from data obtained from GT. GT is like the Chinese GitHub. LFX, the Linux Foundation Insights, the first versions of the tool were using also GrimoireLab. And we, Bitergia, we are using GrimoireLab for a service we call Bitergia Analytics Platform.
So how does the process work? When we collect data, we collect digital footprints, the Git log, the issues, the pull request, comments open, mailing list, emails. Basically, we have 30 different data sources that can be collected to see the activity of the community. We are aware that there's a bias to what can be collected, and not everything in an open source community is captured in a digital footprint. Then we have the enrichment phase where because we have so many different tools we're collecting data from, it needs to be normalized and made useful. And then finally visualizing and reporting so that we can tell the stories or build the risk model that we were showing earlier. One of the key components is an identity merger where a contributor like me, I have many different email addresses. I have different usernames across different platforms. I have been working at different companies. If that is something we want to know, who are the companies in our project? This is something the tool has solved as one of the key challenges. And I also want to be mindful when we talk about personal identifiable information that this needs to be protected, and we need to be mindful about collecting and processing this data. So we have been working with lawyers to make sure we comply with the GDPR, looking at can we do opt-in or do we have to do opt-out, which typically in an open source community, everyone contributing knows we're contributing to the public and the contribution will be known. And having an analysis on the community tends to be for the good of the community, especially when we do this as a community dashboard. And so there's some things, I don't want to get into all the nitty-gritty details, just as a primer to also think about this when using a tool like GrimoireLab. There's a whole architecture from collecting data. I love the names that you decided on for the components, like Percival, the loyal knight that goes out to look for the Holy Grail, or King Arthur that is overseeing the whole process. And the roadmap, there are 3 key things we are working on right now. One is the maintenance effort is high. We want to get that down, have more user interface or APIs to automate things. Scalability, right now it takes a long time to collect data and process it. Parallelizing that, we need to change the architecture, and also providing data into other tools through APIs and allowing users to visualize it and analyze it in different ways. Especially with artificial intelligence, you need high quality data and make it available in different formats. So that's what we are working on there. You're welcome to get started. The tutorial is a great place to start working with the open source version. If you prefer to just work with the tool and get the data, you can also get Bitergia Analytics as a commercial supported version. If you only take away one thing from the talk today, I want to leave you with this thought. We need to understand the risk in our software supply chains. After licenses on vulnerabilities, the focus needs to broaden to include community health. And we have a tool in open source, the GrimoireLab tool, that is the de facto industry standard that can help you get started on that journey. With that, thank you. We are welcome to take any questions.
Thank you very much. You've talked about the work that you've done to pull a picture of health out of all these multiple layers of dependencies. And it's a lot of work for you. For example, the disambiguating a user's name. And I wonder if there's an opportunity to do things also from the other direction so that people or projects can push information upwards. You know, you can go on GitHub and you can get an instant picture of open pull requests, open issues, and so on. But if there were a systematic way for such projects to project other data about themselves, more not just about pull requests, but that gave you those kind of metrics that you're working hard to pull out, would that be of value? Would it even be possible?
Yes, I have some thoughts. In the Chaos project, we are talking about how projects can do that and how they can signal their health in different areas through badging, through having files that have that information. I also know the Cyclone DX community is thinking about how to integrate some of that information into the SBOM that the Cyclone DX standard supports. Do you have other thoughts, Luis?
No, I was thinking that for most of the open source ecosystems, it is very relevant to be neutral for foundations, for instance. So if the public data and the metrics for that is something that is beneficial, not only for the ones producing the software, but also for the ones consuming the software. So I think it's an interesting idea.
Thank you for the question. We are at time. We're happy to connect with you after the talk as well. Thank you so much.
Thank you so much.